Okay, let's see how you did on these. I'm going to go ahead and just move these problems down and get them out of the way. So for the first one, 2.86 times 4.7. When we multiply with decimals, we ignore the decimal points. So we've got 7 times 6, which is, careful, 42. There we go. Carry the 4. 7 times 8 is 56. Plus the 4 is 60, so 0, carry the 6. And 7 times 2, 14, plus 6 is 20, so 0, carry over the 2. Now, before we move over to the next digit, we do have to put in a 0 down here. And I'm going to put a line up here so I know what's new carries. 4 times 6, 24, so 4, carry the 2. Perfect. 4 times 8 is 32, plus 2 is 34, so 4, carry the 3. 4 times 2, 11, plus 3, or 4 times 2 is 8, plus 3 is 11. There we go. So 1, carry the 1. And we add them up. We've got 2, 4, 4, 3, 1. And the decimal point, we have 1, 2, 3 decimal places in the answer. We start at the end of the number, we count backwards, 1, 2, 3 decimal places here. So we had 3 decimal places total in the original problem. We had to have those 3 decimal places in the answer. Also, you can think of this as being about 3 times 4 or 5. That comes out to be 15. We better get an answer close to 15, which is the 13. Over here, 13.4 minus, I line up my decimal points. Remember, when we add or subtract, we have to line up the decimal point, because when we add or subtract, we must have the same name. So put in the decimal point there, 48392. I'm going to fill in my zeros here to fill in my missing places. 0 minus 2 can't be done. I go all the way here and make that a 3. This is a 10. We'll have to keep borrowing. This is going to be a 9 and a 10, and I borrow again, 9 and a 10. So now, 10 minus 2 is 8. 9 minus 9, 0. 9 minus 3, 6. 3 minus 8, going to have to borrow. This will become a 2 and a 13. 13 minus 8, 5. Now, the decimal point didn't affect us when we borrowed, but before we move on, we do have to carry it down into our answer, bring it down. 2 minus 4 can't be done, so we borrow, that's a 0. This is now a 12. 12 minus 4 is 8. Any questions there? Adding is pretty simple. We just have to remember to line up our decimal points. So write down the first number, we put in our decimal point. And just like with subtraction, I'm going to fill in my missing decimal places with zeros. Not quite as important with addition, but still helps. So 0 plus 4, 4. 9 plus 8, 17. So 7, carry the 1. Before I do the next column, I bring down the decimal point. 1, 3, and 9 is 13, carry the 1. 1, 7, and 2, 10. So 0, carry the 1. So 103.74. Now this next one, 32.764 divided by 3.15. I start out writing it like this, but I can't divide by a decimal, remember. We have to move that over. Had to move it over 2 spots here, so I have to move it over 2 spots here. So this is going to become 3,276.4 divided by 315. Does 315 go into 3? No, not yet, no. So we leave it blank above the 3. How about 32? Nope, so we leave it blank above the 2. 327? goes in there once. So 315, we subtract, we've got 12 left. We bring down the next digit, which is the 6. Does it go into 126? No. Now, since we've already got a digit there, we've got to put a 0 in here. Now, before we bring down the 4, we carry up the decimal point, bring down the 4. 315 into 1,264, 4 times. That is 1,260, we subtract to get 4. Are we done? No, we wanted to go to the nearest thousandth. Even though we're out of decimal places here, we can add zeros and bring them down. So 315 into 40, of course, is 0. It does not go. Add another 0 and bring it down, because we're only at the hundredths place. 315 goes into 400 once. Now are we done? We're at the thousandths place. We have to go at least one more digit. Because we need to know, is that going to stay 401 thousandths, or does it have to round up? Well, 315 goes into 850 only twice. That's 630, which is going to give us 220 when we subtract. So since that next digit is a 2, this is going to stay 10.401 is our answer. What do you think? It is what it is? Okay. Well, one of the other things we learned was convert to a fraction. .875. Now remember, this is 875 is the numerator. What's the denominator going to be? Tenths, hundredths, thousandths. Or remember, 3 digits, 3 decimal places here, 3 zeros in our denominator. So now what? Have to reduce. Both can be divided by 5 will work. 25 would work. I've got 5 on there, so let's do 5 first. So we've got 175 over 200. Now they can actually still both be divided by 5 or 25. Let's do 25. 175 divided by 25 is 7. And 200 divided by 25 is 8. So 7/8. How about 0.84? I want you to try to do that one in your notes quick. So this is going to be 84 over 100, yes. Tenths, hundredths, or 2 decimal places, so 2 zeros. Both of those can be divided by 4. 84 divided by 4 is 21. 100 divided by 4 is 25. So 21 over 25. How about this? 17.0325. How do we convert that? Yeah, the 17 doesn't do anything. So what we're converting is the 0.0325, which is going to be what? 325 over 10,000. Very good. Tenths, hundredths, thousandths, 10,000ths. Now both of those can be divided by 25. 325 divided by 25 is 13. 10,000 divided by 25 is 400. And that's it. So we are done there. So we got to remember, put that with the 17. So 17 and 13 over 400. Any questions? Okay. A little bit trickier was problems like this. Convert to decimal. Now, of course, the way we did this, the calculation was simply to do what? 5 divided by 16, yes. Numerator divided by denominator. For doing it with a calculator, of course, you just punch it in, but doing it by hand, 16 won't go into 5, so we've got to add the decimal point, take it up, and add the 0. Does 16 go into 50? Yes, it does. It goes in there 3 times. 3 times 16 is 48. There's 2 left. Adding another 0. Does 16 go into 20? Sure does. That's 1. 1 times 16 is 16. There's 4 left. Add another 0. Does 16 go into 40? How many times? Twice. 2 times 16 is 32. There's 8 left. Add another 0. Bring it down. 16 goes into 80. Careful. 5 times 16 is actually 80. So we get 0. So 0.3125, and it comes out exactly. We stop there. The tricky part is when they don't stop there. We might have something like, oh, let's see here. 1/60th. That's going to be 1 divided by 60. $60 does not go into 1, so we had the decimal point and a 0. Does 60 go into 10? No, so we've got to put a 0 here. Add another 0 down here. Does 60 go into 100? Once. So that's 60. There's 40 left over. We'll add another 0 and bring it down. 60 into 400. 5 would be, oh, let's try it. Let's do 5. 5 times 60 is 300. We subtract, we've got 100 left. Well, that's bigger than 60, which tells us we could have taken it out more. So we'll go up to 6. 6 times 60 is 360. That's 40 left. Add another 0. Bring it down. Well, at this point, you might notice this was 60 going into 400, and once again, it's 60 going into 400. What's that answer going to be? Yeah, it's going to be another 6 here, which would be 360 again, which would still be 40. So it's always going to be a remainder of 40, which means it's always going to be 6. So this is going to be 0.016 with a bar over the 6 to indicate that 6 repeats over and over again. We might have 3 over 110. So what should go inside here? The 3, the 110 outside. 110 does not go into 3, so we add a 0 and a decimal point. 110 goes into 30. Nope. So 0 and a decimal point. 300. Twice. So that's 220, subtracting to give us 80. Add a 0. 110 going into 800. 7, so it's 770. That'll be 30 left over. Add a 0. 110 goes into 300. Twice, that's 220. Now you should see a pattern here again. We had 300, 220, 300, 220. Left with 80, left with 80. We're going to be in that repeating cycle again. So what's going to repeat this time? 27. So this is 0.027 with the 2 and 7 repeated. So the key is getting the correct digits repeating there. You might have 5 over 21. I'm going to have you do that one in your notes quick. See what you come up with. So this is 5 divided by 21. Put in the decimal point, add a 0. 21 goes into 50. Oops, I didn't get a 0 here. 21 goes into 50 twice. So that's 42. There's 8 left over. Then what? Add a 0, bring it down. 21 goes into 83 times. That's 63. So it's 17. Add a 0, bring it down. 21 goes into 170. 8 times would be 168. That's 2. Add a 0, bring it down. 21 goes into 20. 0 times. Add a 0, bring it down. 21 goes into 200. 9 times. 189, that's 11. Add a 0, bring it down. 21 goes into 110. 5 times is 105. That's 5. Add a 0, bring it down. You might be getting really tempted to call it quits on this one and say, okay, yep, not going to repeat. But what do we notice here? Right now we're at 50. 21 goes into 50 twice. 21 times 2 is 42. That's an 8. Let's see, we had 50 minus 42 is 8. 50 minus 42 is 8. So we are starting to repeat. This is a 6-digit repeating pattern. So this is going to be 0.238095. Repeating. So some of them you just got to be patient with. Even if you're doing these on the calculator, like 5 divided by 21, it might be hard to recognize the repeating pattern because it's such a long pattern. You're looking at this 238095 2381. That round off really throws you off. Seeing that 1, your eye doesn't pick up on the repeating. So you do have to be very careful with those. I wouldn't ever give you anything that had more than 6 digits repeating in it like this, but there are actually some of them, the division by 13, some of those actually have 12 digits that repeat. So those won't even appear on your calculator screen. Okay. We can also then have things like this. On a problem like this, what would we have to do first? Well, it's just order of operations. So, well, first level of order of operations is enclosing symbols, right? So we see parentheses. So we're going to start in the parentheses. Within those parentheses, we still go through the order of operations. Any other enclosing symbols in there? No. So second level is exponents, powers and roots. Do we have any? Yeah. 3.2 squared, which is 10.24. So I replace that with a 10.24. Now I'm still inside those parentheses. Any more powers or roots? Okay, what's our next level? Multiply and divide. So 17.28 divided by 1.2 is 14.4. What's next? Inside the parentheses, do we have any other multiplication or division? No. So we're left with division and subtraction. We're going to work left to right. So 15.4 minus 14.4 is 1.0, or just 1. Then we have the addition. 1 plus 10.24 is 11.24. Now I'm down to a single number inside the parentheses, so I can get rid of the parentheses. When I get rid of the parentheses, I have to remember to do what? Put in the multiplication there. So now, no more enclosing symbols, no more powers or roots. So we're just going to multiply the 2.1 times 11.24. $23.604. And now we just have addition and subtraction, so we're going to go left to right. So 3.8 plus 23.604 is 27.404. And the 27.404 minus 11.7 is 15.704. Now the nice thing about problems like this is if you're careful about how you enter them, you can enter them in your calculator and it will spit that out. You look confused. No? Resting? Okay. So I can put in 3.8 plus 2.1. Now some of your calculators you can just put in parentheses. Some of them you have to put in times. I'll put in the times. On mine I actually don't have to. It'll assume it, but I'll put it in anyway. 15.4 minus 17.28 divided by 1.2 plus 3.2 squared, close parentheses, minus 11. Did I miss a digit somewhere? Yes, I did. The 1 didn't go in there, did it? There we go. 15.704. There it is. So I'm going to have you guys try this on. Try that one in your notes. So when we have a problem like this, we have to do everything that's on top first. Then we have to do everything that's on bottom, and then we have to divide. Because that fraction bar across there is this thing. So on top, what do we have to do first? The power. 1.2 to the power of 3 is 17.28, or 1.728, I should say. 1.728. Then what? Well, we've got addition and we've got division. Which one has to happen first? It's going to have to be the division. 1.728 divided by 7.2 is 0.24. What's next? So all that's left is to add. So you get 4.04. So on top is 4.04. On bottom, what do we have to do first? Parentheses, right? Inside those parentheses, we need to divide. 6.4 divided by 4 is 1.6. And then we do have to do the subtraction in there. 1.6 minus 0.1, 1.5. Now we are done with the parentheses. There's only a single number left inside the parentheses, so we can get rid of them. Do I have to put in multiplication in front of my parentheses? No, not here, because there was already subtraction there. What's next? Multiplication. 1.2 times 3 is 3.6. And then subtract. 3.6 minus 1.5 is 2.1. So this is 4.04 divided by 2.1, which is going to become 40.4 divided by 21. 21 goes into 40 once. There's 19 left over. Before we can bring down the 4, we move up the decimal point. Then we bring down the 4. 21 goes into 94 8 times. That's 168. Oops. Goes into 9 times, doesn't it? 9 times is 189. There's 5 left over. Put in a 0, bring it down. 21 goes into 50 twice. 42 with 8 left over. Now, if you're paying attention in the last problem and thinking back, you'll notice this is going to repeat now. 21 goes into 83 times. That's 63. 17 left over. Add a 0. 21 into 87 is 6. It's 168. 2 left over. Add a 0. 21 does not go into 20. Add a 0. 21 goes into 200. 9 times, that's 194. Leaves us with a 6. Add a 0. 21 goes into 60 twice. (42) that's 18. Add a 0. 21 goes into 180. 8 times. That's 168. That's 12. Add a 0. 21 goes into there 5 times. And if you see, what were we? I'm just going to divide this out here. Actually, I'm not going to do it on that calculator. It won't work. I'll do it on this screen. This one should repeat, if I remember right. Doesn't? $40.0 or 4.04 divided by 2.1. It does repeat. I got a mistake in here. This should have been 8, not 6. Oh, yeah. That would be an 8, not a 6. That's why I didn't look familiar. I did multiply by 8, but I wrote down a 6. It is 1.923809.5. Then 238.095. 238.095. Blah, 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 blah. So it's 1.9 and then 238.095. Where the 238.095 repeat. So somewhere in about here, I screwed up. Yeah, this should have been 184, not 194. 189, not 194. Oh well, it's Monday. That's why the calculator's there for backup, right? Okay. We're a couple minutes early, but let's go ahead and take our break here. And we'll come back and we'll look at some new stuff, some more new stuff. Okay, so for our second hour, what we're looking at is we're dealing with solving equations now with these decimals in them. Like 4.2x minus 8.4 equals, oh, let's do 2.1, make it simple. So when we look at an equation like this, just like when we had fractions in our equations, they look more complicated because of the decimals being in there. But this is really no different than an equation like this. And when we went to solve an equation like this, where did we start? Yeah, we added. So over here, we're going to do the same thing. What are we going to add over here? The 8.4. So it makes that minus 8.4 go away. And we're going to add 8.4 over here. So on the left side, the 8.4 is gone. We just have 4.2x. On the right side, we have 2.1 plus 8.4 is 10.5. Then what? We divide by 4.2. X equals 2.5. So it's the exact same process. So we have 5.8x plus 3.1 equals 17.6. Where do I have to start? Subtract 3.1. So it's gone on the left side, leaving me with just the 5.8x. On the right side, 17.6 minus 3.1 is 14.5. Then what? Divide by 5.8. So over here I just have x 14.5 divided by 5.8 leaves us with, oops, I got something wrong there. Let's try that again. 14.5 divided by 5.8 is once again 2.5. Well, we can make them a little bit more complicated than that. We can have 1.3x minus 7.4 plus 2.3x equals, oh, let's do 5.2. Where do I start here? Combining the x's. 1.3 and 2.3 make 3.6x. I still have the minus 7.4, and it equals 5.2. What's next? We'll add the 7.4. So 3.6x equals 12.6. And then divide by 3.6. So x equals, did it come up before exactly? It comes up to 3.5. There we go. X is 3.5. Is that my applause? Is that the applause?
Oh no, it's the rules based.
Oh no. So let's have 2.9x minus 4.8 equals 1.5x plus 5.4. Where do we start here? Okay. Since we have an x on each side, we have to get rid of one of them. The smaller one is the 1.5, so I'm going to subtract 1.5x. 2.9 minus 1.5 is 1.4x. I still have the negative 4.8. Over here, all that's left is 5.4. Then what? Add 4.8. 1.4x equals 10.2. And then divide by 1.4. X equals 7.285714286 approximately, right? $7.2857114 repeating. Remember one of the things that we mentioned, I mentioned that calculations are about patterns. That's one of the patterns is learning to pick up on repeating decimals. And when you start to see a decimal repeating, here, I could calculate that out to 1,000 decimal places if I wanted to, because after 6 it repeats. Once you pick up that it repeats, then you just keep saying those repeating digits over and over again. It will tell you on my math lab what to round it to. It'll tell you whether to mark it as repeating or to round to the nearest hundredth or thousandth, or round to 2 decimal places or 3. Or it'll give you that. If it asks you to mark it as repeating, remember you're going to have to look down at the little menu, and in the menu you pull down the menu and you'll have the little fraction thing and whatever. There will be one that'll have like gray boxes with a bar over it. So you have to select that out of that pull down menu to mark them as repeating. I don't think my math lab this time around has you mark them as repeating. I don't think so. But I mean, it does have that ability to. So looking at this one, we have parentheses, which always should draw our attention in. Looking here, is there anything I need to do inside those parentheses? No. So the next question, of course, is what do I need to do to the parentheses? That's multiplying by the 1.2. 1.2 times 3.1 is 3.72x. 1.2 times a negative 4.3 is negative what? 5.16 equals the 15.7. Then what? We add 5.16 to both sides. 3.72x equals 20.86. And then? Perfect. We divide both sides by 3.72. So 20.86. Yes, I know, no yawning. Divided by 3.72. Looking at this one, does it appear to repeat? It actually does not. Excuse me. So we're going to go, we're just going to say that we were told to go to the nearest thousand. So what would that round to? 5.608 to the nearest thousand. If you look at it, you got tenths, hundredths, thousandths. That next digit is a 5, tells us to round that up to an 8. Well, since we have a little bit of free time here, I want to look at these repeating decimals more. If I have 0.6 repeating, I want to be able to convert that to a fraction. To do that, I'm going to use a little trick. Let's say that I tell you that x equals 5, right? If I then give you the equation that 5x plus 2 equals 27. Now you recall we were told that we could subtract the same thing from each side of an equation. And it won't change the equation, right? Add, subtract, multiply, divide, actually. So here, if I subtract 5 from this side, I would get 22. I also have to subtract 5 from the left side. But rather than subtracting 5, since I know that x equals 5, I'm going to subtract x. So it's now 4x and the plus 2 is still there. Is that still the same equation as we had up here? It is. X is still going to equal 5 in there. So even though it looks like I subtracted different things here, because x equals 5, subtracting 5 from one side and x from the other is the same. It's subtracting the same thing from both sides. So now back to 0.6. If I let x be 0.6 repeating, now you'll recall that's really 0.6666666 and going on forever. They all repeat, right? If I multiply both sides of this by, let's use a dot instead of an x there. How many digits repeat? This is the same one digit repeated over and over again, correct? So I'm going to multiply by 10 because only one digit repeats. If there was 2 digits repeating, I'd multiply by 100. 3 digits repeating would be 1,000 and so on. So x times 10 is 10x. 10 times 6.6. 10 times anything just moves the decimal point over a spot, doesn't it? So this is going to become 6.66666, or 6.6 repeating. So here's my new equation. from that new equation, I want to subtract that original 0.6. I'm going to subtract off the repeating decimal. So 0.6666666, right? That leaves me with just 6 over here. On the left side, though, instead of subtracting the 0.6, I'm going to subtract x, because my original equation said x is equivalent to 0.6 repeating. So 9x equals 6. So now x, to solve for x, I divide by 9. So x equals 6/9, or 2/3. Most of us probably knew that 0.6 repeating is 2/3. So that makes sense. Well, what if I have more than one digit? What if I have 0.45 repeating? Well, then we let x equal 0.45. And then instead of multiplying by 10, we're going to multiply by 100. Because we have two digits that repeat here. So x times 100 is 100x. Moving the decimal point over 2 spots here, this is 45.45 repeating. And then I'm going to do the same thing. I'm going to subtract that 0.45 repeating, which will leave me with just 45 over here. On the left side, I'm going to subtract x. So 99x. Now I'm going to divide by the 99. So x equals 45 over 99. And of course I can reduce that. Both of those can be divided by 3, which will give me 15 over 33. Divided by 3 again. 5/11. So 5/11 is equivalent to 0.45 repeating. What if I have 0.282 repeating? It's going to be 1,000 we're going to use, exactly. So I'm going to let x equal that. And it's 3 digits that repeat, so I'm going to multiply by 1,000. So this is going to be 1,000x equals 282.282 repeating. What am I going to do next? Subtract the repeating part. 2.282 repeating, which leaves me with 282 on the right. On the left side, I'm going to subtract the x. 999x. Now we'll solve by, I don't know why I'm putting extra decimal points. Divide by 999. So x equals 282 over 999, and we're not done yet, because both of those can divide by 3. 94 over 333, and I believe that's as far as it can be reduced. So 94 over 333 is equivalent to 0.282 repeating. What do you think? No fun? Actually, let's do this. Oh, why not? What the heck? 0.416, where the 6 repeats, no, not the 4 and the 1. So we're going to let x equal 0.416 with the 6 repeating. Now, before I do anything here, I need to adjust this. The process we've been using requires that the only thing after the decimal point is the part that repeats. So here I've got two places that do not repeat. So what I'm going to do is I'm going to multiply by 100 there to make that 41.6, so the 6 repeats. So I multiply by 100 here, so I have 100x. So that's where I'm starting, is at 100x equals 41.6. Now, I still want to do the same thing. I want to move it over for the repeating decimal. There's only one digit that repeats, so I'm just going to multiply by 10. So 41.6 repeating is 416.6 repeating. 100x times 10 is 1,000x. So now here's where it gets tricky. What I'm going to subtract is not the original piece up here. What I'm going to subtract is this piece. I'm going to subtract 41.6 repeating, because that has that 0.6 repeating. It's going to cancel out those repeating digits. So 416 minus 41 is 375. What do I have to subtract on this side? 100x. So 1,000x minus 100x is 900x. So now to solve this, we are going to divide by 900. So x equals 375 over 900. And both of those can be divided by 25. 375 divided by 25 is going to be 15. 900 divided by 25 is 18. And still divide by 3. 5. Something's off there. What did I do wrong? So that shouldn't be 18. That should be 36. That's what's wrong. So that should be 5/12. So what do you think? Loads of fun? Yeah. I mean, it's a neat little process if you know the repeating decimal to be able to find the equivalent fraction. Every repeating decimal can be turned into a fraction, no matter how ugly it is. For example, we might have 0.6285714, where the 285714 repeats. So of course we're going to let that equal x. But again, we have to do a first step. What are we going to multiply in this first step? 10, because we've got one digit that doesn't repeat there. So we got to move it over that one digit. So 10x equals 6.285714 repeating. Now, what do we have to multiply by? Well, we've got 6 digits that repeat. So we've got to multiply by 1,000,000. How do I know it's a million? Well, for every digit that repeats, I need a 0 in that multiplier. So 6 digits repeat, I need 6 zeros in that multiplier. So on the left side, 10x times a million is 10 million x. On the right side, 6.285714 repeating times a million is 6,285,714.285714 repeating. What would our next step be? Do I go all the way back up to here? Say no. No, I go up to here. because that has the repeating decimal that I need to get rid of. So I'm going to subtract 6.285714. That's going to cancel out that repeating decimal. Well, I still have to subtract the 6. This is 6,285,708 now. What am I going to subtract from the left side? 10x. So this is 9,999,990x. So we're going to divide by 9,999,990 to get x equals 6,285,708 over 9,999,990. However, both of those numbers can be conveniently divided by 2. So it's 3,142,854 over 4,999,995. You lost? Yeah. Do you understand how I got to here? Sort of. I'm just reducing it now. So I divided both of them by 2. I think they're both divisible by 3. Let me see here. Yes, they are both divisible by 3. Actually, they're both divisible by 9, I believe. They are. Let's divide them both by 9. So 3, 4, that's going to be a 3, 8, 9, 206. So 339,206. 5, 5, 5, 5, 5, 5. That's interesting. So we get that. Is that as far as we can go? Probably. I think there is still something we can reduce there. I want to make sure I divided this right. $349,206. That's where that problem is. That'll make a difference. Now they're still both divisible by 3. That's why I was off. 349,206 over 555,555. They can both be reduced by 3. So here I'm going to get 116,402 over 185,185. I'm going to double check those. The answer to that is I don't hate you guys that much yet. So the hidden warning there is don't upset me. Just saying. Now, can either of those be reduced? I think that is it. I think we are done there. Here, we'll double check. So we get that decimal, same decimal we had. And let's do math. We get a fraction. See what it comes up with. Oh, nope, it could have been reduced more. I thought it could be reduced more. It comes down to 22 over 35 eventually. Yeah. No, I don't hate you guys enough to make you do something like that. But it is interesting to see that it can be done by hand if you're not tired and make a lot of mistakes in your math. The other side of that is, of course, I was doing this quickly. I wasn't writing out my division. I was doing it in my head as I went, which maybe not the greatest idea on a Monday morning. Okay, let's step back here a minute and talk about word problems. Because I know everybody wants to talk about word problems. Let's say service call costs $34.75 per call plus 45 cents per mile. How many miles were there in a $55.45 call? So here what we have to do is write an equation. The service call is $34.75, so it's 34.75 plus 45 cents a mile, so 0.45x, where x is the mileage. That's going to equal our cost, price. Well, if the call cost $55.45, put $55.45 in for the cost. And then we solve this just like we did the equations we were doing up above. So I'm going to subtract 34.75. So I got 0, 7, 20.70 equals 0.45x. Now I'm going to divide by 0.45. So x equals $20.70 divided by 0.45. Should give us 46 miles. We can get into some of our problems like we were talking about before, where we're going to sell bats for $8.25, balls for $4.50. We sell 3 times as many balls as bats for a total of $652.50. I want to know how many of each sold. So I'm going to put my bats and my balls down here. And we start out with the number sold. Well, it says 3 times as many balls as bats. So I'm going to have to let x be the number of bats. Balls will be 3x. But we don't have the total number sold. We have the total dollar amount. So we have to turn it into dollar sales. And remember, that is the price times the number sold. So for bats, the price was $8.25 times x is how many were sold. For balls, that's going to be $4.50 times 3x is the number sold. Well, 450 times 3x is 1350x. those two numbers have to add up to the 652.50. So 8.25x plus 13.50x equals $652.50. Now what do we do? Combine. Very good. This is going to be 2175x equals 652.50. And then divide by 2175. X equals 652.5 divided by 21.75. 30. Now we have to make sure we go back and answer the question. X was the number of bats. That means there were 30 bats sold. 3 times X will be 3 times 30, or 90 balls sold. I think you guys have had enough for one day. There is a new quiz. It is due for tomorrow. That is Tuesday, 11:59 p.m. There is new homework that is due for class time Wednesday. Actually, it's due at like 1 o'clock Wednesday. Just a warning. Test 3 is coming up next week on Thursday. I believe that is, what, April 13th? So just be aware, we are coming up on a unit test. Okay, I'll let you guys have the last 15 minutes to get started if you want. The computer lab next door is available. Otherwise, we'll see you on Wednesday.